Okay, today we're going to be doing proving lines parallel, which will be the converse of our theorems we learned in 3.2 about parallel lines. If you have parallel lines, then you have certain properties true. We're going to do the converse of that to prove lines parallel. So we'll be able to prove successfully that lines are parallel. Little cartoon here. I don't know. I found that today it hasn't exactly been that many people that found this very funny. However, you see how this guy says parallel lines never meet, and then this guy says he'll bet him 5 clams. Okay, it's in the Stone Age. People are apparently, that was a good thing to get. I don't know. So anyway, it's not that funny, but anyway, he says you're on. So they both take a stick, and I don't know what this is about, but he's being silly. And then he yells at him to stop it. And so they start drawing their lines in the sand, and they're walking and walking and walking, and they're just keeping their lines parallel. And then they stop after they go quite a ways, and he says, stop. And he goes, see that? They meet. And he makes the guy give him his clams. Well, why does it look like that? Yeah, if you get further and further away, right, you can't see the distance between them is still there. Okay, it looks like they converged. That's like a perspective drawing, you know, in art. So anyway, this guy's like, what? Because he looks back and he's like seeing the point there, and so he goes and he starts walking back. He gets to the other end and he's like, hey, you know, they didn't meet. So he had been right in the first place that parallel lines never meet, but he got upset and he's kind of mad that he gave his clams away when they in fact did not meet. Okay, so obviously that was just for fun. All right, so let's do something that's actually what we're doing today, and that would be the corresponding angles converse postulate. Now, I'm not going to have you write that corresponding angles converse postulate is why you're doing it. I'm going to have you write something different, and I'll make a short version for you. The first thing we want to realize, though, is that two lines are cut by a transversal so that the corresponding angles are congruent, then the lines are parallel. So parallel comes last today instead of first, like when we did 3.2. So this would be, in short, if you have corresponding angles congruent, oops, I forgot the S, corresponding angle is congruent implies parallel lines. Okay? I want you to know what it says. So this is how we're going to write it when we're saying, if I ask you what postulate or theorem are you using to show the answer, you're going to have to give me this. All right? So in this picture, if angle 71 here, this angle 71, and this angle down here would be the corresponding angle. If lines M and N are parallel, then we would need these angles to be congruent. So we would set up 2x plus 3 is equal to 71. We would subtract 3 from both sides, and we would get 2x is equal to 868, and we would then divide by 2, and our answer would be 34. Okay, one example. Okay, so the second example is very similar in that it says, find the value of x that would make line A parallel to line B. These are also corresponding angles. They're just on the other side of the transversal, and they would need to be equal if lines A and B were parallel. So setting that one up, add 7. I'm going to show less steps here. Divide by 5. You should be getting 21. There's another alternate interior angles converse, and that says that if you have alternate interior angles that are congruent, then that would imply the lines J and K here are parallel. So we would say abbreviation, alternate interior angles congruent implies, or then you have parallel lines. Okay. Your next box on that page is about alternate exterior angles, and it's the converse of the alternate exterior angles converse. So it would be, if you have alternate interior angles congruent. Alternate, sorry, not interior. I just did interior. These are exterior. My mistake here. Make that EXT. If alternate exterior angles congruent, then you've got parallel lines. That's our abbreviation for that one. And finally, the consecutive interior angles converse says that if consecutive interior angles are supplementary, then you have parallel lines. Remember that 3 and 5, if those are supplementary, then J and K must be parallel. Same side of the transversal. Okay. Back here, these were on the exterior, and this was on the interior. This is the one where you have the backwards Z or the S. Okay. All right, and then one more, perpendicular transversal converse. That's just saying if two lines are parallel, are perpendicular to the same line, then the lines have to be parallel. So if there's a right angle here and here, then that would mean that these two lines must be parallel. Two lines perpendicular to same line. I don't really have an abbreviation for this. Then they're parallel. That's supposed to say line, not lime. Okay. All right, so let's see what we're going to do with these. There are 5 ways to prove the two lines are parallel. Corresponding angles congruent, alternate interior angles, alternate exterior, consecutive interior angles supplementary, and 2 lines perpendicular to the same line. The first example you have, example 2, says is a proof. Okay, example 2. In the figure, it says that line A is parallel to line B. Okay, so the ones that are given to be parallel are here and here. Okay, if those are parallel, which is given, the first line, the next question, next part, number 2, says angle 1 is congruent to angle 2. That is not a given. Angle 1 is congruent to angle 2 because of the parallel lines. If you have parallel lines, then corresponding angles are congruent. Angles 1 and 2 are corresponding. All right, so that's based on, you see how right here, this has been given, then this reason for the next statement is usually based on that, all right? That's why it's parallel, then corresponding angles congruent. Okay, next it says in the proof that angle 1 is congruent to angle 3. That was actually given. All right, now I didn't mark anything yet. I have to do 1 and 3 congruent, so I'm going to mark that. Now, why is angle 2 congruent to angle 3? Well, you can't do the picture. Don't use the picture. I don't want you to go here because you're going to make a mistake if you do. See this? I bet somebody's got it though already. You got 1 and 2 congruent, 1 and 3 congruent. So putting that together to get this would be by substitution, or they may think transitive. Okay, it would be substitution or the transitive property. I would take either answer. Okay, then finally, why are lines X and Y parallel? Well, because angle 2 and 3 are congruent. What are 2 and 3? Okay, so now I'm paying attention to this line, and they're saying those are parallel now because 2 and 3 are alternate exteriors. Good. So if you've got alternate exterior angles congruent, that makes you have some parallel lines. So that's what today's about, proving the lines are parallel. And that would have to be last if you're proving that. Okay, so that would be the last part of the statement. So do you see, I really want to clarify here, guys. Pay particular attention here to the difference between writing one like this and writing one like this. This one is already given parallel lines. You get to say stuff. And the last one is, because I want to prove lines parallel, I have to have something already true so I can say that they are parallel. And that comes last. All right? So when you're proving lines parallel, you're doing the converse where the parallels are being at the end. So let's try another. In this next one, we have been given angle 1 congruent to angle 2 and angle 1 congruent to angle 3. So I'm going to go mark that on my picture. 1 congruent to 2 and 1 congruent to 3, which would imply 2 and 3 are congruent by taking 1, 2, 1, 3, making a trade, substitution or transitive. Okay, so you don't have to have both answers. I just want one, one of them. And then why would the lines be parallel? Let's see what lines they're saying are parallel. AB parallel to DC. And that's because those things are what kind? Alternate. Switch sides, jump over on the inside. So that's if, well, you don't have to write, I don't care if you write the word if, but you can. Alternate interior angles congruent. Then you get parallel lines, which is the converse of the alternate interior angles theorem. Feel okay so far? I hope so. Do anybody still need this? Okay. So now this one's got the reasons scrambled up. We're going to complete the proof, number the reasons to match the statements. All right, so I'm just going to look at my proof as I go. I'm going to figure out angle 1 and 5 are complementary is a given. So that's, I'll put a 1 in the first given. And the next thing says something about complementary. That's also been given. So that's 2 is the next given. And then angle 5 is congruent to angle 6 is also a given. So that'd be the third given. And then it says angle 1 and 2 are congruent. Well, angle 1 and 5 are complementary. Angles 2 and 6 are complementary. And 5 and 6 are congruent, which make 1 and 2 congruent because of the congruent complements theorem. So angles complementary to congruent angles are congruent. That's what it says. So this is choice, what number? I'm on 4, right? All right, that was why 1 and 2 are congruent. So let's see, anyway, that's what I've got so far. These are congruent to each other. Those are congruent to each other. And then angle 1 and 2 are corresponding angles. Well, that's what, they're in the same position, okay? Along these lines right there. So since they're in the same position, that's the definition of corresponding angles. That would go right there. 5 is actually on line 5. And then the lines are parallel because if corresponding angles are congruent, then the lines are parallel. So that's 6. Okay, hopefully not too bad. You think you could do something like that, match them up? Cool. Now, these are the type of questions more like what you are going to have to do in the assignment. You do have a proof in the assignment. Find x so that L is parallel to M. Well, if x is if L is parallel to M, then these guys right here have to be congruent, which means 3x plus 15 has to be equal to 90. And the postulate is, what kind are they? What's that? Alternate You got heard it right. Alternate interiors, right? Alternate interiors. So alternate interior angles congruent. That implies parallel lines. Needs to be in that order. We solved this guy, and I was at 75, and then you divide by 3, get 25. Okay, moving to the next one. On number 6, for L and M to be parallel, these angles, which would be in same position, these are corresponding angles. If they are congruent, then we've got some parallel lines. They're in the same position. That's why I knew to write corresponding. All right, so 5x plus 20 equals 70. Solve that, and you get x is 10. Okay? Okay, now, I'm so tired of hearing myself. I'd love to hear somebody else's voice tell me what kind of angles these are and what I should write for my theorem. Okay, Darylyn? Perfect. Alternate exterior angles congruent means you've got parallel lines. Great. And then what will we do? Well, we said congruent, so I bet you're already setting it up, right? 6x minus, oops. I'm starting with the 6x just because I like to get the bigger x's on the left, but whatever. 5x minus 5. Okay, so solve that carefully. Got x minus 20 is negative 5. Bring down that minus sign. If you add 20, you should be getting 15 for your solution. Okay. Someone want to tell me what to write for my reason on number 8? Oh, we did this one quite a bit already today, haven't we? Lexi? Yep. Alternate interior angles congruent, then you get parallel lines. That's it. 6x equals 4x plus 20. All right, and then that was all I was going to do. Basically, the rest is your homework assignment. I could get you started, and then we're going to move over to the graphing some equations of lines. So what we're looking for here, guys, it says state the postular theorem that justifies your answer. If I'm going to do 3 and 7, angle 3, angle 7 being congruent, that would be up here having to do with these lines. So the postulate would be if alternate interior angles are congruent, then we get parallel lines. Okay, and then you would, that's already, oh, what lines would be parallel? Would be A parallel to B. And then I'll look at the very last one, on number 4. 5 and 12 adding up to 180. These are on the same side interior. Those are consecutive interior angles. So consecutive interior angles supplementary would imply parallel lines. and we're supposed to determine which lines would be parallel. Well, if you just look at what makes them, it has to be the L and the M. L parallel to M. Okay, you have some questions there to finish up. We can answer questions on them on Friday. So, all right, this is the more graphing worksheet that we got today as well. So we want to practice graphing some lines. There are 3 lines we have to graph on the quiz tomorrow. When we look at an equation, it should be in y equals m times x plus b form. If it's not, then you want to put it in that form. Therefore, you can see the slope number. It is the number in front of x. It is not including the x. And you can see the y-intercept, which is where it crosses the y-axis. The blue line is the y-axis in my picture. I had those highlighted. And then we're going to go ahead and graph these lines. So the answer to what the slope is for number 1 is -2, the coefficient of x, and the y-intercept is +6. A slope of -2, you think of it as a fraction by putting a 1 on the bottom. And that would mean to go down 2 and right 1. And then we're going to start, though, at 6 on the y-axis. So this is where we start, and then we go down from there 2 and right 1 and make a new point. And we go down 2, right 1, and we do that multiple times. I like to see my grids full, or get it, I don't like stubby little lines. You can go reverse of down 2, right 1, which we up to left 1. Okay, the slope on the second line is 1/3, and the y-intercept is -2. We're going to start at -2 on the y-axis. I know this is review, guys, so I'm not going very slow. We go up 1, right 1, 2, 3 from our y-intercept. Continue to do that, and then you can go backwards by going down to left 1, 2, 3. And we get some nice straight, they better be straight. I'm trying to hit them. Didn't do too bad. Hit the points would be nice. Now this one's jumbled up on number 3. The number in front of the x is -1/5. That is your slope. Remember, do not write x down in the slope blank. It should not be there. X does not belong there. X is just where you locate the slope number. 3 is the y-intercept. So we start at 3 on the y-axis. -1/5. Oh, I guess I should have explained that -2 means down 2 and right 1. That's why I was going down 2, right 1. A -1/5 means down 1 and right 5. So I go down 1, right 5, and a down 1, right 5 again. Or up 1 and left 5, up 1 and left 5 again. Oh, I missed. There. Okay. They may have a line they want to pick out that we'd like to go over. Then I'm going to give out the review in a minute. Let's do number 6 quick. What is the slope of this line? Okay, what is the y-intercept? Yep, if there's not one there, it's 0. You start at 0, -3/1, down 3, right 1. So I go from here down 3, 1, 2, 3, and right 1. And I just do that 2 times. Or up 3, left 1. All right, then let's jump to special case number 9. It says y is 5. Well, where'd the mx plus b go? Well, what one of those things is there, but this is missing, isn't it? So if that's missing, then m must have been 0. What's the y-intercept? Well, that's that number, the 5. They're all straight, but I get what you mean. You're thinking that it's going to, if that's where the y-intercept is, it has to stay at 5 all the time. It's a horizontal line because it slopes 0. Okay, and then 10, what kind of line's that? Yep, it has no slope, or the slope is undefined. It doesn't have a y-intercept. It just goes -2 forever. No matter what y is, the x is a -2. Okay. All right, so now we're looking at the review for the quiz 3-1 to 3-4. We're going to do just the front side today, and then tomorrow we will do the back page before we take our quiz, and then ask any last-minute questions. This kind of question is still going to be coming up. What plane is parallel to plane HJK? I've had some students have trouble with this. This was actually the picture that was on the last quiz. This is HJK, that's that plane. What plane would be going the same direction as that one? Like, because like this one's connected, it wouldn't be there or there. And then over here, it's not flush with it. Cadence? Right over here? Okay, yep, that's it. So you can use any 3 letters that are in those 4 letters representing that plane. These planes are parallel, and that is, I guess the one that names it is this one, right? EFB. But you're right, the name ECB is a good name for it. It just wasn't the one they listed. All right, name the intersection of plane ABC. Now I'm going to find plane ABC is this front side right here. Okay, and I can't believe, all right, I had students on the last quiz so clueless about this, and I'm not sure what it is that makes it so difficult. I've never been able to quite figure it out. I had people write a point. Is there any way for 2 walls of your house to meet in just one little dot and stay together? It's impossible. You got to think about planes as being like walls or ceilings and floors, and well, that would be parallel planes. The ceiling and the floor is an example of parallel planes. The wall and the ceiling meeting has to have a big seam, and that seam is a full line. Plane JKA, where is that? Oh, there it is, JKA, that'd be right here, this whole side. All right, now, where are the green and the blue meeting? You see the A and the D? And then we're not going to write just a segment because we're thinking of a plane as extending on and on. The only way we can draw it, though, is to have it stop on the picture. So this would be where they intersect. So it's line AD or DA. Doesn't matter what order you write those letters. All right, now skew to DA. DA is already drawn. That's a big blue line. I want something, remember skew lines? They were lines, and I had this one picture on a paper that represented it very well, and it looked kind of like this, where one goes under the other, and they are in different planes going in different directions. That's not a very good second drawing there I did, but oh well. Okay, so since I got to twist and go different ways, if I check DJ, DJ has D in it, so it hits it. There just can't be that. LG, process elimination, LG's back here. It runs the same direction as DA. You want to answer? Okay. And FB, so LG's no good. FB, that's going to go like that. Will it ever run into that line? It's going to go right past it. So that's a good one. And then BA, oh, BA hits it. No way. Okay, now these questions are just asking us to identify alternate interior, alternate exterior, corresponding or consecutive interior angles. So I go find angles 8 and 10. Oh boy, we did this one a bunch today. Bing, bing, bing. Got the Z. Those are alternate interior. Angles 3 and 13 here and here. Oh, they jump over the transversal. They're way on the outside. So these are alternate exterior. I bet you already have these. Why don't you answer the next two while I'm busy writing? See if you got them right. 6 and 11. Oh, there they are. They're in between lines on the same side. They're called consecutive interior angles. I could have written angles on these. And then finally 13 and 15. That's going this way and this way. Down here, same side of the transversal, they are corresponding. They're in the same position. Okay, now if you're given that A is parallel, oh, I have a page I don't, wait. Oh, sorry. We already answered all those. I'm trying to answer this now, and I didn't like that I couldn't see 9 and 10. All right. You already have the answers to all those. This was alternate interior angles. This was alternate exterior angles. This one was consecutive interior. And these were corresponding. Okay, the transversal for 7 and 15. If you want, I'll use a highlighter here. 7 and 15. Now, they are on the same side of the same that's the transversal. That'd be line C. Okay, given that A is parallel to B, for the next question, and the measure of angle 6 is 82. If that's angle 86 is angle 2, find the measure of the following angles. Angle 11 would be its supplement. So it would be at 180 minus 82, which is 98. Okay, and then 12 would be 82 because they're alternate interior to the angle 6. So 11, we're going to find the value of x. Can somebody give me a way to find a value of x? Come on, guys, get it. It's Daryl, she's always going. More of you know. Cadence and Daryl, only one want to answer questions today. Lexi did so for me too. One. All right, Cadence. All right, Daryl. Only look at the X. Look at the parts with the X's. Kenny? Okay, why are we going to get to do that? So say I asked you for what theorem you used. And you see how A and B are given to be parallel? So that would be, if you're parallel, then alternate interior angles are congruent. That's not what we did today. The converse, we weren't proving the lines parallel. So they gave us the parallel lines. So we're set these equal, and then we're going to subtract 3x. You guys are pretty much experts almost now. Most of you are experts in solving these algebra equations. Add 7. 2x is 24, so we should be getting x is 12. Now, I had to finish that one because I need to use that 12. So I'm going to have to plug it back in. So what's 5 times 12 minus 7, please? It's 53. You know what I did twice today? 43. And no one said a word. Because I went really quick, apparently. All right, these are both 53. All right, now, that means now that the 4y, you see how these are on the same side interior or a linear pair. So 4y, whoopsie, plus 3 plus 53 equals 180. All right, make sure you do some of your homework, finish up graphing those lines, finish up this quiz review, the back side, or make sure you know which ones you want to ask so we can check it tomorrow before we take our quiz. And have a nice evening. Timer, time out.